Okay, so here we are at the end. We've calculated the pH here, here, a little bit back from there even, here, and now we're into the dilution region. So we are going to use the dilution equation. Because we're past the equivalence point. And so that's really, I can't emphasize this enough, it's really key that you know where you are on that titration curve. Because that's going to decide what you do. If you think you're in the wrong spot, you're going to do a completely wrong calculation. And so, again, this all started with drawing a sketch. I mean, I did it first to introduce, but if I saw this, first thing I would do is this. Seriously. And then I'd figure out what these volumes were and work off of that. And so now we know we're past 25. So now we're into the, God, I'm drawing all over my hand today. What's going on? Anyway, how's that for staying focused? So we're 10 milliliters past the equivalence point. Because we were past the 25 milliliter value. So that means we're working with 10.00 milliliters of unreacted sodium hydroxide. Okay. And we have a total volume that is equal to our 25.00 milliliter, our sample that we started with. So it's the total volume of stuff in the beaker. You know, what's in the beaker? Well, 25 milliliters of our sample, 35 milliliters of our NaOH. So all told, that is 60. Okay. And so when we set up our M1V1 equals M2V2, M1, that's our initial molarity of our NaOH, which was 0.1 molar. I even remembered to write that in the first place. I didn't have to do a little caret and splice it in there. Pretty good, yeah. 1 out of 2 ain't bad. If it was baseball, I'd be in the Hall of Fame. If it was basketball, it would depend on what type of shot it was. If it was free throws, I would not be, probably. If it was three-pointers, I'd be the greatest of all time. Alright, anyway, so this was, if it was soccer, I don't even know if they track shooting percentages. I don't know how that works. Hockey, I think that would put you in the all-time greatest. Half the shots at goal go in. I don't think anyone does that. What else is left? Football, I don't even know how that would work in football. Alright, so V1 is our unreacted NaOH. So 10.00 milliliters. Okay, not bad. M2, that's what we're figuring out. So I'll put a question mark. V2, that's our total volume of 60.00 milliliters. Alright, and so, you saw me do it before, I'm going to do it again. You can't stop me. I am an algebra machine. Okay, so M1, 0.100, the worst kind of terminator, a mathematical one. Alright. Yeah, gonna do some integrations next or something. Oh, that's not a prereq for this course, if you even know what I'm talking about. 10.00 milliliters. We'll just plug it in our numbers. You can tell when I start getting to the end of the week and the end of the videos here. Alright. I've been trying to think of and we solve it. Another amazing literary analysis, and I'm coming up short this week. Although I will say, I was thinking about it, so I was like, you know, I cracked The Hobbit last week, so I was like, well, you know, there's the Lord of the Rings library that goes with that whole thing. And I think the moral of that story is that ignoring your problems doesn't mean they go away. And so what do we got here, by the way? So this is equal to our concentration of OH minus, because that's what we had extra of, right? So NaOH means that this is our concentration of OH minus. They're like, oh yeah, that volcano and that tower over there sure seem active. I'll deal with it tomorrow. So we're going to calculate our POH. Yeah. And that's just the negative log of that number that we got right there, 0.167. That's a 1.78. I guess there's a whole other set of books, the Silmarillion, which is like there's like The Hobbit, and then there's like Lord of the Rings, and apparently this one I've only read The Hobbit, or like whoop, just huge. I don't know. I don't think that Tolkien guy got out much. Let's see. So 14 minus 1.78. I'm not even explaining what I'm doing anymore. Like, I've done it so many times. Alright, so pH equals 14 minus POH. That's 12.22. Does that make sense? Sure, why not? It's a high value. Okay. Let's see. The 0.1 molar, 0.100 molar NaOH by itself. That's going to be a pH of 13. You can check that if you want. So as long as you're somewhere between, what was our last number? What did we get before? It was 8.2 and 13. You're good. All right, so we finished the problem, right? We solved this. Granted, it was a 5-part problem, but it was still one problem. All right, part 1, 2, 3, 4, and 5. I hope you're really starting to appreciate the beauty of that middle one still, because that's like a free data point, right? Doesn't get any better than that. Okay, so we are done with the weak acid titration. So next we're going to do polyprotic. I'm not going to go into as much detail. So if you're unsure of how to do any step, if you're interpreting a curve or whatever, like, this is your walkthrough on the math. Alright, there's a couple shortcuts of the polyprotic I'll talk about, but if you had to calculate something in a buffer region, like this, then this process I talked about here will get you there. If you had to calculate something in the dilution region, this process would get you there. If you had to do an equivalence point that has an ice table, or the initial value with an ice table, well, A, we've talked about that one already, and B, this will be your go-to. Alright, so we'll get into polyprotic acids next.